Hello, everyone. Good afternoon. Thank you for joining us. Welcome to this webinar on a review of Postgres SQL replication approaches. My name is Violet Sia from Enterprise DB APJ Marketing, and I will be your host today. Our presenter today is Boriss Mejias, Solution Architect at EDB. Before we get started, here are just some housekeeping items. All the slides and recording will be made available to every one of you here very soon via email. And if you have a question, please submit it via the Q&A box, which you can see at the bottom of your screen. So thank you for joining. And without further ado, I will hand the floor over to Boriss. Over to you, Boriss.
Thanks a lot, Violet. So I'm very glad to be here presenting for the first time in the APJ area. It's nice to be here with you guys. In fact, this presentation I've given already before, but I adapted especially for this region. I learned a lot about the culture in terms of heavy metal and the area. So you will see when I present it. Now, the title I put myself as a holistic system software engineer. This is a fictional term, you could say, and the term holistic referred to my conviction that when you approach a project, you have to look at it from all the angles, not just the system, not just the software, the whole thing. It's a holistic view. Of course, the official title is Solution Architect, and in one of the meetings, I've been told that I should also explain which kind of projects I've been working on, so that people can get kind of more like an interest in what I'm saying. so as a solution architect, I work mostly on a replicated system currently. So that hence about replication that I'm going to talk about is something that I like a lot. And I especially work a lot in BDR, bidirectional replication. But I'm not going to talk about that today. I'm just going to talk about all the possibilities that you have in open source PostgreSQL for the replication. And I'm also an air guitar player as a hobby, and it's just fun. If you want to comment anything on Twitter, I really would like to have your feedback on the presentation, on both topics, replication and music. And also, if you have ideas for presentations in the future, that will be really, really great to have some of your input, because we want to continue doing webinar. We want to continue spreading the knowledge of Postgres so people use Postgres more. And your feedback is very important in order to have that correctly. So why this presentation? Why talk about replication? Well, replication is something that is very useful for multiple goals. It can be for achieving high availability on your system, which is probably the thing that is the most requested, but also in order to increase the availability to read more information at once, not depending on one single node. So kind of scalability. So scalability and high availability are the main topics here. Now, if you watch already Postgres build in the conference that we have at the end of last year, I did a very similar presentation, but that one was quite shorter, and I didn't have the interactive part with the console that you're going to see. I'm going to be doing some tests on the Postgres itself. So this one is going to be more complete in that term. If you already watch the global webinar, well, this is an improved version. I made a few mistakes there, and this is a better version. So it's always good to refresh the concept and relearn things. That's one of the reasons why I also like to do presentation, because I learn a lot, because I repeat myself and I say, okay, I didn't figure out about that in the first time. So let me continue then. Now you know why we are going to see this topic. And the reason why I mentioned air guitar music, and because I like to mix the things that I like, the things that I'm passionate about. And I would like to talk about music. And there's an album called Open Source by Kiko Loureiro, released last year. So it's very fresh. Kiko Loureiro is an excellent guitar player from Brazil. He also plays now with Megadeth. He used to play with Angra. And he created this album inspired by our community, not Postgres community, but the open source community in general. And his music is now open source as well. So he created this album where he released all the tracks for the musicians and for the listeners, so that you can listen to only the drums, for instance, or only the bass, and you can modify it yourself. So he's promoting people to write his own pieces of music based on his composition. So it's really not just the name open source that sounds like a good marketing strategy, but also the philosophy on open source. So that's very important, I think. So that's why I commented it, because it's mixing two of the things that I like a lot: music and open source, and especially heavy music, which I like a lot. And what we're going to get to at the end of this presentation is a diagram where you're going to see that can be made a little bit like a too bloated for you now in terms of information. You see many types of arrows, many types of heads of arrows, many type of communication between the nodes here. These are all Postgres nodes and a backup of the node. And the different colors are different versions of Postgres, older versions, newer versions. And the type of arrows represent different kinds of replications. Some of them are physical streaming replication with synchronous or asynchronous. Some others are logical replication, and some others are for streaming for backup. But you're going to see at the end that when you look at this picture again, it's going to be like very easy to understand. So that's my goal. If you understand this picture, it means that you know different approaches for doing replication, and you're going to pick up the best for your use case. So that's the idea, that you learn multiple tools and then say, okay, in this case, I think I'm going to use this one because it fits better my use case. Okay. So a PostgreSQL replication is actually a variation that is coming from some other roots in PostgreSQL, in the same way that heavy metal is actually a variation of blues and rock. When they asked me, when Violet invited me to give a talk here on APJ area, I was wondering whether heavy metal was something that I should talk about or not, because it's mostly considered into the Western culture. But actually, I am from Chile. I'm from South America, which is also not part of the Western world in terms of culture. And for us in South America, heavy metal is very big, not just because it's cool, but because it resonates with our way of thinking and trying to not be in the stereotypes of society. So that's why I thought, okay, I'm going to investigate a little bit in this area. And actually, it resonates in the same way in countries like India and Indonesia, how this kind of a way of thinking is kind of away from this mainstream, actually. And this is also what open source does. And if you look at people that listen to heavy metal, it's really passionate people in the same way that we are open source passionate people. So, and the roots of heavy metal are in blues and rock. And the same way, the roots of replication, PostgreSQL replication, are in backup and recovery. So that's why I'm making you the mix. So you remember that replication actually comes from backup and recovery. We are going to see details of that. So you have PostgreSQL. I hope you can see the mouse here. You have here the RAM. Yeah, so this is something more volatile. When you read access to your database, all the information is going to go from the data directory up to the RAM, and then you're going to read on RAM. But if the server crashes, the RAM is gone, and then you need to have a way of recovering from that crash. So everything that happens in RAM here in Postgres, I said that you want to read something. So here are the backends connecting to the share buffers. They get some information coming from the data directory. They can read it and then modify it. Whenever you modify something here, immediately goes to disk. Immediately goes to what we call the WAL, the write ahead logs. So this is a chain of changes that happens on the database. So you can use always this change of changes to recover in case of a crash and this goes away. Yeah. So this is the basic of how data is being modified in PostgreSQL. Now, when you want to take a backup, in case that not only your RAM is gone away, but also your disk is gone, what you want to have is a copy of that data directory plus a copy of all the changes. So whenever you have this combination of two things, you can restore your database. So this is the basic principle of backup and recovery. So the recovery, what is going to happen is that you start another instance and you have your share buffers again, and then you feed all your memory from the data directory plus the changes that come from the wall. So that will be how backup and recovery works. And the good thing is that at the beginning of the century, the elders of PostgreSQL had a very good idea, and they said, like, why don't we just stream all these changes all the time, and we do a constant recovery. So we are always doing a recovery. We don't wait until we crash. We are doing it all the time. And this is actually the basic for replication. So you're, instead of copying files with a wall, you have a process which is called the wall sender, which is reading from this wall directory. So it's reading all this chain of changes and is sending them through a stream to the wall receiver at the other machine, which is also running at the same time. So your recovery is always recovering all the time. You don't wait until they have a crash. So the receiver is going to send information to the wall directory. So it's feeding constantly the source of changes. And from that, it gets to the shared buffers again, and it makes it available for all the processes here. And because the changes are immediately available here, this is what we call a read replica. Yeah. So at this point on, we don't talk about anymore backup and recovery. We talk about replicas and read replicas. So this node here is known as the replica or the standby, yeah, or sometimes secondary node. This one is known as the master and the primary node. There's a controversy now about the name master. I like to still use that concept. Is if you think about music, for instance, you have a master copy, and from the master copy, you can create all your copies of your albums and music. This is not just for heavy metal, of course, for all types of music. So in that sense, I'm using the terminology master here. And it also because when we go to logical replication, we are going to talk about multi-master, which makes more sense than multi-primary. If you have multi-primary, nobody's a primary, you know. You have to, a primary actually means that one is more important than the other. Okay, so replication comes from backup and recovery, and now you know why. And understanding this change of stuff as a change of changes is important, because you see that all the changes come in one single stream. That means that all the changes that happens here in parallel are going to happen sometimes faster than the change of changes that goes here, and that sometimes you get replication lag. And that's important to know this concept when you take decisions about your architecture. Okay, so because of these roots, the way of knowing whether a node is a master or a replica, it is by asking whether it's in recovery or not. So on a master node, if I ask, is the node in recovery, it's going to tell you false. It's not in recovery because it's a master node. And if you do that on a replica, then it's going to tell you true. There is no query, PG, is this primary, or PG, is this replica? No. In fact, you are going to see when it's cascading replication that it is difficult to tell whether it's a replica or not. So let me move to the slides here. I'm in a Postgres database running. This is select version Postgres 13 running on a Debian. The name of the database is called BOA, not like the snake, but this is a reference to Bangalore Open Air. Bangalore Open Air is a metal festival that happens in Bangalore since 2012, and it's sponsored by Wacken Open Air, which is Wacken Open Air, one of the main metal festivals in Europe. So let me tell you the query here. Select PG is in recovery, and it tells me false. Okay, so I know this is a master node. And let me find my other node here. So for some reason I lost my other console, but let me connect to another one. So minus FSSH, let me connect to Mumbai. Yeah, and then I will do Postgres PSQL. I can connect also to the database BOA, so you see it's the same database. And this one I'm going to do select PG is in recovery, and it tells me true. So this one is actually a replica. I don't know exactly whether it's the replica of this node or not, but it is a replica because it's in recovery. What I can tell you is the primary connection info. So this is not a tutorial about how to install Postgres replication, but I want to tell you all the important concepts that you need to take into account so that you know what to do in terms of building up your architecture. Okay, so here in the primary connection info, it tells me to who is connecting to, and it tells me that it's connected to Bangalore, which is the node that I had here, and it's connected as itself as the node Mumbai. Yeah. Now, know that I didn't put the password here. That's very important when you configure your replication, that your password is actually configured on the PG pass, so that you don't have to put it on the information of the database. Okay, so you can hear not just music and heavy metal, but also pop music and stuff like that. Sometimes the singer of the band, he shouts to the crowd like, "Can you hear me?" And the crowd goes wild like that because the people, the artists want to know whether they are being listened or not. Like in this moment, I don't know whether you're listening to me or not. But because of that, we have a poll. We have several polls actually today. So Violet is going to start a poll now, and we want to know whether you're using replication or not on Postgres. So this is my shout to you as a follower of the webinar, whether you're here listening to me or not. And so you feel free to answer the poll. Okay, there you go. You get the polls there. You can answer the polls. I'll continue with the presentation. I'm going to move the poll here. In the terms of PostgreSQL, the replication is always being monitored. So you have a table called PG underscore stats for statistics underscore replication. This replication is actually going to be present in all the primary nodes. So whenever you have a primary node, it has this information. Okay. Yeah. So in terms of the information that you have here on this table, you can see the LSN is a log sequence number, which means all the changes that are being sent from the primary node to the replica. So you can have here what is being sent is this value, and what is being received, it has three different places. What is being written to disk, what is being flashed to disk, and what is being replayed, which is available on the shared buffers. I'm going to go back to this concept again. So this is in terms of the name of the change. And this is in terms of how much time passed since it was being sent and being acknowledged by the replica when it's being received in all these three stages again. So this is the lag. This is how you monitor the lag. And it tells me also that it's asynchronous communication. Yeah. With this information here, I know that this is the Mumbai node. And as the node that I show you here on the presentation. So if I go here and I query here, select, let me change the display, select everything from PG, stats, replication. You can see I have multiple replicas. One of them is Jakarta, and it has also all this information that I tell you, the LSN plus some lag, and then here you have Mumbai. Yeah. So this is real information. I'm not just making slides. Okay. There's a little bit of more information here than the slide that I show you, but I mean, I don't want to bloat you with all the information. This is the main important one. So I told you that there are 3 points of measuring when the information is being received. One is here on the wall receiver. When it writes to disk, it's the same that when you copy something onto your, you know, when you put your USB stick and you copy things to the USB stick, you always have to unmount it before you take out the USB stick. Otherwise, the information is being corrupted on the USB stick. Okay, so the flash is the second part. So you write here first to the disk, and the flash goes from the kernel to the physical disk, and you know that everything is being completely safe. So when you say like it's being written, you know that it's being received in RAM. When it's being flashed, you know that it's on disk. So then you really have a guarantee. And then when it's being replayed, it's made available here on the shared buffers. So that means that you can read it. So those are the 3 places. Okay, so let's make a break now and let's go back to music. So heavy metal, as I told you in the beginning, is a variation of blues and rock. Okay. On top of heavy metal, you can have multiple variations. One of those is power metal. Power metal is happy music. Is mostly coming from Europe, I would say, and it's very huge in South America as well now because we want to be happy with this music. And if you talk to people who listen to power metal, you will see that the mindset is set on a future world when they live in happiness and they say the word tomorrow without fear. And we also have our motto in EDB, which is power to Postgres. And we also have to see the future of Postgres without fear. Okay, so a small variation, you upbeat, and then you get power metal. Now another variation, you add a violin in the music, and then you get folk metal. So it's very similar to power metal. The topics are very similar, but it has a violin, and the upbeat is not as fast as power metal. So it's folk metal when you have a violin, and if you put many violins, you get symphonic metal. which is very epic and stuff. You have very, very interesting stuff in symphonic metal. It comes a lot of influences from especially Bach and Beethoven and those kind of music. Now, of course, it's not just violin. I did some research, and I know that in India, for instance, there is it's not really folk metal; it's more like progressive metal when they use sitar to play rock and heavy music, which is very interesting. So and there is a band called the Who. They're from Mongolia, and they use an instrument called the morinkur. I hope that I pronounced it correctly. And this one actually create a very special folk rock or folk metal. They not just the instrument, is also the way of singing. They use a technique called the Mongolian throat singing, and they create this very special sound. So you can see the mixture of cultures is very interesting to have it in music, and it kind of unifies us all as a community. And I see also the parallel with the open source community here. And why I'm talking about this, because with the small variation that you add, you have a different style of music. In PostgreSQL replication, if you apply a few changes, you get a different approach to replication, and you can solve a different use case. So I told you the roots of this tree of PostgreSQL replication are on backup and recovery. Yeah, it is called physical streaming replication when we have the main core, the trunk of this replication. And from that, we get the cascading replication as a variation of the typical physical streaming replication. And this is when you replicate from a replica. So it's cascading your replication. You add another modification, and instead of saying all the changes are asynchronous replicated, they become synchronous replicated, and you have a different approach, which has a concept of having less data loss. Okay. Now, adding something more disrupted is logical replication, because this one actually changes the way of thinking about your architecture. Synchronous replication, asynchronous is a small change. Cascading replication is a different change, which is also small. But logical stream replication actually changed the game, and it's very important. We are going to talk about it soon. So asynchronous replication, you have a node here, which sends a change of changes to the replica. And then you can have multiple replicas, as I show you on the screen. And then you can have asynchronous replication here going on. Now, when you connect, you don't have to connect only with one channel to the database. You can have multiple channels to connect. And what we recommend is that when you talk to the master, this is your read-write connection. And if you connect to the replicas, it is a read-only connection. If you try to write, it's going to fail. So it is going to be read-only. At the level of the applications, you know when your queries are read-only, so you can split them very easily instead of parsing them automatically all the time. So what we have here is that you can read actually from 4 nodes, and this is what we call read scalability. So you add multiple replicas so that you can take the charge of reading out of the master node and do that on the replicas. This is what we call read scalability. So it gives you a different approach. See, it's a small modification, but you get a different approach. And this is what we call horizontal read scalability. Now, in terms of robustness, which is a different use case, you can have one data center that has 2 nodes, again, the same as asynchronous streaming replication from the master to the replica. And then in a different location, a different data center, you have, again, the same stream of changes. And in that one, you have cascading replication. So what this is going to help you is to reduce the amount of data that is being transferred from one data center to the other data center. So if there is a failure here, you can easily come back to the second data center and already have the architecture of a master and a replica. So your strategy is being recovered much faster. Okay. So let me put some names here. I say that the master here is Bangalore, and I have 3 replicas. One is Mumbai, the other one is Beijing. And from Beijing, you can replicate to Sydney. Yeah. So these cities actually, they appear in a documentary called Global Metal, and they visit all these places. Sydney doesn't appear; it appears in a different one called the Headbangers Journey. And so the idea is to you can understand how this music is being appreciated in different places. Now, the difference is really a fine line between cascading and normal replication. In cascading, you have the Bangalore, which is the primary node, Beijing is one of the replica, and Sydney, you saw there's a different replica. The only difference in the primary connection info, which I already show you, it is the host. So one is going to connect to Bangalore, the primary directly, and the other one is going to connect to our replica. And that's how you do cascading replication. And it's not more difficult than that. Of course, every node have to identify itself with its own name. So this is important here, the application name, so that the master nodes who is connecting to. Yeah, it's not compulsory unless you want to do synchronous replication, which is what we're going to see next. Now, note that here, Bangalore, Beijing, the node here, Beijing, is going to have the statistic replication as well for the Sydney node. So although it's not a master node, it can also inspect that value. Yep. So it's going to have two information. What about the receiver information and also about sending the information, because it receives and it sends at the same time. So it receives information and sends at the same time. So you have two tables actually for monitoring the replication. Okay, so let's increase the robustness. If you want to have automatic failover, it is necessary to have a third data center, or at least a third node, which is your witness node. It doesn't have to be a full Postgres node, but it's like an eye. You see the eye of the beholder, which is looking at the other nodes. And it's observing whether they are running or not. Why do you need to have a third one? Because one of the most difficult problems in distributed computing or replication in this case, it is to know whether your source of information is dead or only the channel between the two is dead. You know, and web conferences now that we all do in these times, you never know whether your network is gone or the computer of the other person actually crashed, and that's why your connection actually dropped. Yep. So this point here is very difficult to know for this node here, actually impossible. So the only way to know it is actually through another third party, which is the eye of the beholder here, the witness, which is going to tell you, actually this node is running, so don't do any promotion. Still stay as a replica. The node is running, it's fine. Just you cannot talk to it at the moment because somebody cut the wire here, or somebody updated the firmware of the router, and then you cannot talk anymore. Now the problem is when you have a network isolation. The important thing of having three here is that three or five nodes, but three locations, is that you can always have a majority. So if this node is actually isolated and not really a crash, he can say like, okay, I'm in a minority, probably I should shut down and not continue. So this is fencing. This is a concept of fencing, protecting the failure part. And then this one is between the two of these are going to decide, yeah, this one have to be promoted, and then is going to be a new primary node. Okay, so it's network isolation. It's very important. So you can achieve that only when you have a witness node. So don't attempt to do automatic failover if you only have two nodes. Very risky, because you can end up having a split brain, and recovering from a split brain is much more difficult and more expensive than recovering from than having to recover in downtime and all the stuff that is longer than what you would like to. Okay, so not only machines fails, of course, human also make mistakes. So a way of protecting yourself from human error is that you have a way of receiving the changes, but don't apply them immediately on the share buffers. So the changes are going to be waiting there. And you can put a timer on it, like don't open this change from now until 3 hours since you receive it, or pause it forever until you explicitly say, I want to resume, and you get all the changes. Okay. So that's what it's called delay replication. So let's get back here to this diagram so that you don't forget all the small concepts. Whenever you do a change here on the share buffers, go to the wall. From the wall is going to be read by the wall sender. The wall sender is going to change that to the wall receiver, and then you have acknowledgement of the replica, either when it's being written to the wall, when it's being flashed, remember exactly on disk, and when it's being replayed on the share buffers. Okay, good. So this is the delay part. Instead of applying it immediately, here you can put a delay. Why do I mention human error? Now imagine here that somebody dropped a table here and it thought that it was working on the test environment or the staging environment. So like, oh no, this was production. And then what you do is that you go to your replica. So you can do point in time recovery, recover from backup, and you get a table, but it takes a lot of time. But if you have this replica, which is delayed, you can do um, pause of the replication and replay only until the moment before you drop the table, actually. So you can recover all the data, reinject back in production, and then you're safe. So you don't have to stop your production if you have this kind of a safeguard. You need an extra node, of course, which is delayed all the time. Now, something important, if all this part went away, it doesn't mean that you stop replicating stuff here, but you stop receiving changes, but you can replay all the wall afterwards. So it's not that you're going to lose the changes. And this one doesn't have to keep them and send them 3 hours later. No, he sends everything eagerly. It's just a replay. It's just only this part which gets delay. It's always good to have diagrams and drawings. So when you can draw something, it means that you understand it. Sometimes I try to explain something, I try to make a drawing, and then I realize like, oh, I don't understand this actually. So I need to rethink the concept. Now let's reduce data loss. And for reducing data loss is when we are going to introduce synchronous replication. Yeah, synchronous replication actually means that when I write something here, I want to wait until it's being received on the replica before I tell the backend here that we are okay. Yeah. So I have here a commit. When is this commit going to be decided as commit? If I have only one node in asynchronous replica, when it goes to here to the wall, it goes back and it says like, okay, it's done, it's commit. And all this chain from the wall sender to the wall receiver and back is going to happen only asynchronously. In this case, synchronous means that I want to have a guarantee that somebody else got the information and then it's going to be received here. Okay. So now it's very important to have a very low lag because you know all this long tour that has to do the node before getting the information committed. Then it is when you are going to decide that the transaction is okay. So look, we have here that this node is replicating Mumbai, and we're going to add it to the synchronous standby names. So this is another property on Postgres, and everything that is in the synchronous standby name is going to be part of the possibilities of replication. And it can be done in 3 different states, either when it did remote write, the write LSN, when it's being flashed to disk, or when it's remote apply, okay, when it's available for reading. So in this case, it's going to be these places. If I have only one node and synchronous commit is set to on, it's local synchronous commit, local to the wall here, yeah? If it is with synchronous standby names, it's either remote write here, on disk, and remote apply on the share buffers. There's another option that if I have local here, is equivalent, exactly the same as on when I have only one node or asynchronous. So I can say like some of the things are going to be local and some are going to be on remote. Yeah, so I'm going to show you a hybrid way of doing it. So we're going to study this part again, and we're going to see how to do it. Now I'm going to add another node here, which is Jakarta. Jakarta is also replicating directly from Bangalore. So I have 2 replicas here in the same location and 1 replica here in Beijing. And this is very important here for doing synchronous replica. Okay. There are different ways of doing it. I can say like the first node in this line of 3, Beijing, Mumbai, and Jakarta, have to reply so that I can consider that is synchronous. If Beijing fails, there's going to be a timeout, and then Mumbai will be the next one, and then Mumbai is going to replay. Now, this is not a very good idea because if you see Beijing is far further away than Mumbai and Jakarta in this diagram, because in a different data center. So I can switch it actually, and then select the first 2, either Mumbai and Jakarta, well, both Mumbai and Jakarta, which are close to the primary, they have to reply, okay? Or I don't have to wait for the first 2. I can select any 2. That could be Mumbai and Jakarta or Mumbai and Beijing, for instance, and then I'm okay. And I consider this as a good replay. So you can play with this first or any. I like any a lot. I have a friend called Annie as well. I also think it's a very cool woman. Then you have to combine the synchronous standby names together with the synchronous commit. So this was the synchronous standby name property. Yeah. And the next property is the synchronous commit. And then you can decide whether it's remote write, on, remote apply, or local. Those are your alternatives. So let's see. Meanwhile, I'm going to talk about now for the hybrid case, synchronous only when it's important, not all the cases. There's a second poll that is going to appear now for you to see whether you're using a synchronous replication or not. Yeah, it's important for us to see what you guys are doing so that we can focus on the webinars and stuff like that. So in this case, what I'm going to have is here, there you go, this is the second poll. Asynchronous when it's important. I put only one. Any one of these three, I'm okay with only one node telling me that it has the data. I know that I'm going to have zero data loss because if the master crashes, at least one node has it. Okay. But the synchronous commit is going to be local. That means that everything that I'm going to be running now is going to be asynchronous. Yeah, it's synchronous with my own local WAL file. Yep. So that's important. And then dynamically, I can say set synchronous commit to remote apply. Okay. So dynamically, I'm going to say that I want this information to be available at the other side. Then what I'm going to do is, this is a festival, so I'm going to have a table for orders. I'm going to insert into orders ID, customer, item, and quantity. So the ID is 2,267,709, which is the telephone number of Douglas Adams when he was writing the Hitchhiker's Guide to the Galaxy. You have here the customer ID, and he's ordering beer, and he's ordering 18 beers. Not because he drinks a lot, but he has a lot of friends, and also 18 if you do the horn symbols, which is the metal symbol with your hand, if you represent that as a binary number, it's number 18. Okay, so this value, when I get this confirmation of being inserted, it means that it's being at least received and replayed by Mumbai, Jakarta, or Beijing. If I don't get that information, it means that one of those nodes is down, and so I could have some data loss. So and then after I've done that, because it's important to have these orders well replicated, I can come back to asynchronous commit. Yeah, so I reset the value to local from remote apply. So let's do the example. I like doing examples. So I have here my node here for the replica. This is Mumbai. Let me open it here and connect to SSH minus SSH config. Let me connect to Jakarta. Sudo minus u Postgres SQL. Okay, so I'm in Jakarta. I'm connect to the same database, and the last one is going to be Beijing. Sudo minus u Postgres SQL, and I'm going to connect to Boa. Okay, so I have these three nodes here. Yep, they're all connected to Boa. And now I have here this one. I'm going to insert now the order. Yep. And just insert, that means that it's immediately available here in any of these nodes. Yep. So, oh, by the way, this is equivalent to do begin. Yeah, I can insert another order. Let me increase the number here. 10. And then I do commit. Yeah, I haven't done commit yet, so it's not available yet. So you can see I'm in the middle of the transaction here. So I'm in node Beijing here. Let me increase the size. No, this is Mumbai. And I do table orders. And you can see I have one value here, which is the previous one. As soon as I do commit here, boom, it gets here replicated. And I can see that there are two orders now. Yeah, but this is all asynchronous at the moment. What I'm going to do is I'm going to set it up as synchronous. So how do I do this? Here. Yeah. This is my set of standby names, and this is going to be my local. What did I do? Set. I'm missing set. Alter system set. Yeah. And now I'm going to reload this configuration. Select pg reload conf. Yeah. So it's true. Now every time that I insert something, yeah, I don't have primary keys and stuff like that here. So I know that it's going to be available here immediately because it's synchronous. Okay. Now the problem with synchronous commit is that if you stop a node, so select, no, this is systemctl stop Postgres. Boom. So I stop Mumbai. I'm going to stop now Jakarta. So systemctl stop Postgres. Can increase the font size. You can see that. And this one is also going to be stopped. This is Beijing systemctl stop Postgres. Yeah, so all my replicas are gone at the moment. And if I try to insert another one here, oh, why did I change this? Because it's local. Yeah, so it is local. It means that I'm asynchronous replicating. Okay, so what I told you is that I can, on the slides, is that I can set this dynamically. So dynamically, I can say set synchronous replication to remote apply. Yeah, so now it's synchronous. Yeah, it was asynchronous because it was local only. So I insert another one, and now it blocks. So because I want to guarantee zero data loss, I'm setting up asynchronous. I need to get an information from a feedback from any of these three nodes, either Beijing or Jakarta or Mumbai. So Violet, can you tell me one of these three nodes that is going to go back to life? Mumbai, Jakarta.
Is it
Jakarta? Yeah, let's do Jakarta. So I can start Jakarta. Okay, so you saw immediately as I started Postgres here, I got a confirmation and I get the information that the data is replicated. So I know that I can confirm this commit for the user, and it continues. So this is how you guarantee zero data loss on Postgres. And this is how you have to make sure that you have at least enough replicas to do this. So in this case, I didn't have enough. So never do synchronous replication with only two nodes. It's very important. And you can decide also to have hybrid stuff. Remember that in the beginning, before I set this to synchronous, I was still running on asynchronous because my synchronous commit was set to local. I could still continue writing. So that's also important. You can have a hybrid kind of system. So I'm going to change the arrow here. It's called synchronous replication. So I set it to a white arrow here. This is fragile because if this one crashes, yeah, you cannot write anymore. Your system is not robust. You need to have at least three nodes to have synchronous replication. So if this one crashes, this one can confirm. So if Mumbai was away, Jakarta was available for Bangalore, so you could write still on the information. Otherwise, you stop from writing. You don't want that. You can have the same strategy, but with two data centers like this. It's also going to help you. You are going to have a little bit more latency if this one crashes, but you still have redundancy and you still have zero data loss. And you can combine them. So the cascading replication doesn't have to be synchronous. This one can be asynchronous again. And the best way would be to have here, for instance, two synchronous and all the other data center is asynchronous, depending on what you want. And you can play with it. You see, this one is asynchronous, synchronous, asynchronous, synchronous. Yep. So intermezzo, before we go to the next topic. When I started to look at the heavy metal part in Asia, I was really nice. It was really nice to discover how this music resonates in India and Indonesia, in China, in the same way that it resonates in South America. There's actually, you have an extension in Postgres called PG Cryptos. Well, there's a band in India which is called Cryptos. It's really good. I like it a lot. It's from Bangalore. Really good stuff. To my taste, of course. But also, I mean, there has a stereotype of metal music that is very aggressive, very violent, but the people actually are very friendly. Maybe because the metal music allows them to release all this bad energy and to canalize it in a different way. So we are ready for more kindness in different situations. So also about books, there's a lot of bands that I started listening because of books. And also books that I started to reading because I knew about the book through music. So all this culture, I think, is important. Why I mentioned this is just because of trying to reduce the stereotypes and trying to build more tolerance in our society. And also because it's nice to build up communities as we do in open source. Okay, so something interesting in this global metal reportage is that in Tokyo, for instance, the way that they approach metal music is completely different. In Tokyo, is they started to assimilate rock and roll in the 60s and 70s, and Deep Purple, and it was huge in Japan, and then heavy metal actually is not something like a different attitude. It's really like a cool thing. It's aesthetics, and the corpse painting is related to something called the kabuki theater. A really completely different approach, but also very interesting. So it's not that one is better than the other, but it's a different approach. It opens artistic possibilities totally different than the other kind of metal. So why do I mention this? Because we're going to go to logical replication now, which is totally different, a different approach to replication. It really changes the way of doing replication. It opens the possibility to have a multi-master and opens the possibility to have bidirectional replication. So it is a game changer. And I think that Japan is also a game changer in metal music. So you already know this. You say like, okay, again, the stream replication, boring. Now you know logical stream replication. And we're going to have another poll, the third poll, this last poll. And whether you're already using replication or not, and maybe if you're not using it, maybe you get convinced to use replication from now. So the third poll is going to come now. What is the difference with the streaming replication? You do have here, when the wall is written, it has some extra information, which is the wall level set to logical. And this wall is going to be decoded by the wall sender. So there's going to be a logical decoding here. It's going to be sent to a logical downstreamer here at the other side. So you see the arrow change now, has some here logical decoding added here. And the downstreamer, instead of playing it directly to the wall, it is going to first apply it through the chirp buffer to apply the changes logically. So as you see, the buffer here is now different. This change could be applied in a different place because the table could be different. And so that means that this could be a version 9.6, for instance, and this could be a version 12, or this could be running Windows, and this can be running Linux. Different system logical replication can give you a lot of different possibilities. And as you can see here, the backends are not just reading information, they're also writing, modifying the shared buffers here, which means that all goes to the walls here. So this is actually another master. So what you have here is a master, multi-master system and logical replication. It's not bidirectional, it's not horizontal scalability for writes, but you have multi-master system already here. So it allows you to do upgrades from version 9.5 to 12. This would be maybe one of the main reasons to use logical replication, because it allows you to have a nearly zero downtime upgrade. Violet, did you put the third poll? Yeah, it's going to come if it's not there yet. So you can also split your database. There you go. Here's the poll. You can also split your system. So the logical replication, you are selective. You can say like only one part of my database or one database is going to go to version 12 and another database can go to version 13. So this is per database, and inside the database, you can have different replication sets. Yep. Now, you can also upgrade the full cluster immediately, not only one node. So what I would recommend you is that you have this gray value, which is very old Postgres running here with a very nice architecture, but very old version. So you set up again a new cluster, which is exactly the same architecture. Everything is replicated immediately, but it's completely empty in terms of data. The data is going to come actually from the master to the other master. Yeah. So all the data is going to be logically replicated. You don't have to stop writing because you're going to move all the data. And as soon as you put new data, the new data is also going to be streamed here. And when you finish streaming everything, then you can say, okay, we can throw away the old cluster, and we have upgraded our clusters to a brand new Postgres. So let me show you progressive metal after I show you some of the real stuff with logical replication. So what I did before, I had, so the Bangalore Open Air is a festival in India, but the people from Tokyo are kind of more advanced in terms of aesthetics and stuff like that. And they do a lot of air guitar playing. And so I have a table called here, air guitar players. Yep. There's nothing here at the moment. Table. Air guitar playing is kind of a sort of yoga. You just do as you play guitar. It's very fun. It's this philosophy of don't take yourself too seriously. And there are some competitions even. And actually, Japan has a few world champions in air guitar playing. So let me add some of those. So the first guy who won the world championship on air guitar playing, he won it twice in 2006 and 2007. This is I don't know how to pronounce this, Ochi Dainoji Yosuke. But also women are doing air guitar playing now. There is one from Germany, but there's also one from Japan, and the woman from Japan, she also won the in 2017, 2018, really recently. Her name was Namani Seven Seas Nagura. Yep. So that's her name. So I just inserted data here. So this is, if I can insert data, it means that I'm a master node, and I can look at this. When you saw that Bangalore was a master node because I'm writing here, and then you can see all the data is there. Well, I changed the way of replicating here. So all the data is here now. I wrote it here and I sent it here. And if I go to my replica here, where was my other replica? Here, Jakarta. So let me get into Jakarta now. Postgres PSQL, connect to database BOA, and then I do table, air guitar. All the information is there as well, you see? So it went from Tokyo to Bangalore and from Bangalore to Jakarta. From Tokyo to Bangalore in logical replication, and from Bangalore to Jakarta in physical stream replication. And because India is now starting with air guitar playing, let me put here a note here. A guitar player as Hari Namaster Anand. As Namaster is like Namaste, but with air is for air guitar playing. There's a name of like Aristotle is a philosopher. There's a guitar player called air guitar player called Aristotle. It's just fun, you know. So I write here. This is important. Look at the ID that I put here. One of the major issues with logical replication is collision, and to avoid collision, I'm using a kind of a jump in the IDs. And if I look at the information here, I can write, and I have here all the new information here that I put. But if I look again back to the table in Tokyo, table guitar players, I don't have the India because this is not bidirectional replication. This is a logical replication from one source to the subscriber. Now, if I truncate the table here, I'm going to truncate the entire data. So if you want to remove data, make sure that you delete, because if you do delete, you're going to delete only all these nodes, but not this thing here. So that's one of the caveats. Now, I have here a primary key, which is the ID, which allows me to do delete. But if I don't have a primary key, I can only send insert only data. Yeah. So it's important to have a primary key for logical replication. Otherwise, I cannot. Let me show you the table. Describe air guitar players. It has to be a primary key. Otherwise, I cannot do updates. So let's say that I made a mistake and I say like update air guitar players sets 2019 set year 2019 where ID equals 4. This works because I have a primary key. I have a way of identifying this row. If this doesn't have a primary key, it's not possible. Yeah. So you can see the change was sent here 2019. There you go. Okay, so now that you know logical replication, we can do something. Progressive metal is a way of mixing different styles, different tempos, very complicated. And you can have postgressive replication, which is mixing stuff. You can do from an old version of Postgres to a new version of Postgres, and then from this version do logical replication. Look at the arrow to another version here. And from this one, it's not bidirectional replication. If I just do this, you want to use BDR, which is another software that we have in EDB, which I like a lot. But you could like one database go here and the other database go from the other direction. It's not bidirectional, it's twice unidirectional, I would say. And this ones can have a cluster, as we show already, Bangalore with Jakarta, Mumbai, and Beijing. And then this other one can have asynchronous replication here for rich scalability, and synchronous replication here for zero data loss with this other node here. Now, these three nodes can still send all the information through logical replication to another node, which is doing all the information for auditing and analytics and all that kind of stuff. And then you also, of course, want to have backups. And backups is not just the physical backup, but also the physical backup plus all the streaming of the data, which can come from master nodes or from replicas as well. So you don't have to always back up from the primary node. You can also backups from the replica and also in a streaming way. So streaming replication can also be applied to backup and recovery. So we started from backup and recovery. We went to streaming replication physical. We went to logical replication, and then we go back to backup. So everything is connected, and the fundamental interconnectedness of all things. Yeah. So now you understand this diagram very easily. If you compare your knowledge now to the first time that we saw the diagram, and now it looks obvious almost. I hope. Yeah. So conclusion. You have a nice tree of replication. We start from backup and recovery. We go from physical stream replication. Adding small changes, it gives you a variation that allows you to solve a different use case. But when you have logical replication, it's kind of at the source of a new tree on top of a physical replication and opens new possibilities. So maybe if you want to have a webinar on bidirectional replication, we can do that as well. Please pass the comments to Violet so she can tell me, yes, people want to know more about that. And let's go back to music. And I want to quote here Kiko Loureiro, which is also very known in Japan. He's a Brazilian guitar player. He made this album, and he said about the inspiration that the open source, actually, the community brings us to a higher sense of the open source, the concept brings us to a higher sense of community and enhances our creativity and possibilities. So that's the thing that we do with our software, Postgres. Postgres is as it is because we share our knowledge and we enhance each other's knowledge. So why not take this concept of open source software to art, to our music? And I would like to give you with us that feeling of community and share knowledge. So with that, I finished my presentation. We don't have too many times for questions, but I can stay here if Violet allows me to stay a few minutes. Otherwise, I'm going to answer your questions via email through the marketing team. So thanks a lot, Violet, and thanks a lot to everybody for listening until here. And I hope that you learned something today.
Thank you, Boriss. Yes, we only have 1 minute left, but there are actually lots of questions. So maybe there's one. Maybe you can just answer one. Someone asked, can we have logical replication and physical streaming replication running concurrently between two nodes?
Between two nodes? No. So as you saw in the example, from Tokyo to Bangalore, it was logical replication. And this is the only stream that I can have in terms of replication. Now, Tokyo can have its own replicas, and those can be physical replicas, or he can also have a logical stream into another node. Yeah. In the node Bangalore, you saw that I have cascading replication as well. So I can have physical replication from Bangalore, but Bangalore could also have its own replication set and can also do replication and logically to other nodes. So each node can have two different sources, can send information logically to somebody else. It can send information physically to somebody else. Now, as a receiver, if you're a replica, you can only receive physical replication, and that's it. You receive the entire thing. If you're a master, you can receive from logical sources. So I hope that answers the question. One thing is sending information, can be both, can be logical and replica. And then receiving information depends on whether you are master or replica. Yeah, I hope that answers the questions. If not, insist that I answer you the question in a different way, please.
Thank you very much, Boriss. I think we are really at the top of, in fact, we are 1 minute off the top of the hour. So thank you all for joining and for the many questions. We will attempt to answer all via email. And so once again, we thank you for attending and look out for our next APJ webinar on EDB Cloud Native on PostgreSQL. So thank you, and look forward to our slides and recording that will be sent to you. Thank you all, and thank you, Boriss.
You're welcome. Bye.
Thanks
for having me.
Thank you. Bye.